Well, hello there. It is December 20th, 2020, 12/20/2020, and we are on day 20 of Advent of Code. Before we get started on day 20, however, I wanted to cover what happened in part 2 of day 19. So we got to the point where we were able to get like half of the results that we were expecting to see to show up, and we weren't able to get the other codes to match. And I was like trying to figure out what on earth was going on, and trying to was reading through, and the thing that broke through for me later on as I was thinking about it was when we branch, and there are two conditions, right? We saw in the code that let me switch over and show you what I mean. We saw in the code that we did this thing where we said if a set works, right? If it's all valid, what we did in the past was we returned. And what that meant was we were kind of aggressive, right, with returning early if we found any matched set. And I guess I wasn't reading carefully enough because in the description it said there's at least one match. It says at least one list of the sub-rules must match, but it doesn't say exactly one of the sub-rules must match. And so that meant that you could have both of them match. And this is important because if both match, okay, if both match, what that leads to, curiously enough, is that it can lead to, or in our case, it definitely was leading to this, and this was the problem. It chops off a different amount of the input. So it's like both match, one went off and had a really deep recursion and it chopped off a lot of letters, and the other one didn't match as many characters, and but it still was good. Like, it just wasn't as deep of a rule set, you know? And so it came back and it was like, but it got ignored. And so that's the sort of thing that led us to have this situation where we ran out of letters. Where we were like, there's still more rules, what's up with that? Especially the ones that we knew were good. And it was because it should have come from a different branch. And so now I'm going to run day 19, and what we're going to see here is that I didn't print out enough things to show you what I wanted to show you. So what I wanted to do is, so what I ended up doing was I needed a way for each of these recursions to return up a list of strings, a list of possible messages corresponding to the matches, rather than just the one, because there could be more than one. And it took me a while to figure out how to do this, because I was on the cusp of redoing the whole thing, basically, because I realized I needed kind of a way to characterize a set of rules versus a single rule, and that the tree essentially needed to branch not like a normal binary tree where all the nodes are the same kind of thing. Our thing, kind of every other layer was like a different thing. So it was like one layer was a rule definition with the break, with the or in it. And that led to the two sets. And so the next layer were just sets of rules. And then each set of rules would have like two things, right? And so those would then branch into their definitions with the or thing in it again. But I did it the hacky way, and I amended our code to wrap this eval function, which has gotten monstrously large, with this for message and messages. So instead of taking a single message, I took multiple messages. The rest of it largely was unchanged. And instead of returning, where we used to do returns, I started appending the candidate message to this responses list, which initially I was populating with tuples of true false, comma, then the string. But then I realized I actually don't need that true false. I just need the string. And I should only append if it's true. And so in the cases where it's not true, like this one where I initially had code where it said append false, why do we include it if it's false, right? There's nothing to say. So I just said continue, and that continue will trigger this for loop up here as it goes through the different messages and effectively skip the rest of the code, which before we were hitting return to achieve. So now down here, what I changed was, if not valid, whereas before we said rule set wrong and did all that stuff, we still do that, we still break. And then down here, when we get something matching, after much wrangling, we needed to, what I have is another matched messages list, which I'm adding to. Now, why am I not just directly adding it to the responses output? And the reason is because I only want these matched messages if, after going through this whole thing, like this only wants to trigger when the rule set is all valid. And so I have this bunch of matched messages which I'm plus equaling and not appending, because our message itself, which was short for rule message, not the best thing in the world, it gets set by the return of eval, right? Which, if we recall, we want eval to be able to return multiple messages. So our message is a list of strings. And so when you add a list with another list, it concatenates, right? And so now we have matched messages, not nested, and I needed to kind of flatten that into responses. And so looking at this now, I realized I could have just done responses plus matched messages instead of doing this list. But same result is achieved. And what I messed up for a while was this was indented 1 times too many. I needed something outside of the for loop that returned a Boolean followed by that list of responses. And so basically, if we have any responses to come back with, then we know it's going to be true followed by responses. And the reason we needed this Boolean is because I still have this valid that's coming back, right? That I need to check if things are valid as they're going. So it got pretty hairy, and there were definitely many points along the way where I was losing faith, basically, that we could get there. Yeah, and so then when we got to the end here, what's interesting is what comes back, right, is the leftovers, just like before, but it's a list of leftovers. And so now we want to say if it's true, and we want at least one of the leftovers to be empty. So let me show you what that run looks like. I didn't actually run it. So that is more printing than I expected. I'll be honest. Oh, it's because, yeah, I was doing this print for the small file, so it was more like that. Okay, yep, I see what I did there. I want this and this. Yeah, these are the two swaps. There we go. So these are the 12 inputs. And so what you can see here is before we were checking to see if the leftover was empty. Now we have a whole bunch of candidate returns, and as long as one of them is empty, we're good. And so I made a little quick one is empty function that just iterates through, and if one of them is empty, right, if the length is 0, then we're just going to return true. Otherwise, return false. And so what was curious here was before I figured that out, I was just looking at these returns, I was like, interesting. And when I added them up without this if valid and one is empty thing, there was a response. There was a 13th response, right? We wanted 12. There was a 13th response that was just an empty list. Not an empty list with an empty string in it, but an empty list on its own, right? There were no valid responses. What surprised me was that meant that even though I had an empty list, it was returning false, or responses was false, right? Like, why didn't it return false? Like, somehow I wasn't checking valid correctly. Like, that's a weird little edge case. But basically, as long as there was one that was left over, we were good to go. And we counted them up again, and it worked. And I was really relieved that it worked. Let me uncomment this. All right, so we're back to the original state here because I don't know, I was really running out of options. So with that out of the way, let's dive into day 20. I have the usual setup here. Switch over to Chrome. Let's go back to the main list. Take a look at our nice little picture that's coming together, and get ready to go into day 20. So we'll hit start and launch into it. Ready and begin. Jurassic Jigsaw. The high-speed train leaves the forest and carries you south. You can see a desert in the distance. Since you have some spare time, you might as well see if there's anything interesting in the image that MIB captured. All right, decoding those satellite images, you discover the data actually contains many small images created by the camera's camera array, or the satellite's camera array. The camera array consists of many cameras. Rather than produce a single square image, they produce many smaller image tiles that need to be reassembled. Okay, that is something. Each camera in the camera array returns a single monochrome image tile with a random unique ID number. Your tiles arrived in a random order. Worse yet, the camera array appears to be malfunctioning. Each image tile has been rotated and flipped to a random orientation. Your first task is to reassemble the original image by orienting the tiles so they fit together. To show how the tiles should be reassembled, each tile's image data includes a border that should line up with adjacent tiles. All tiles have this border. All borders line up exactly when the tiles are both oriented correctly. Tiles at the edge of the image also have this border, but the outermost edges won't line up with any other tiles. Suppose you have the following 9 tiles. Oh boy. By rotating, flipping, and rearrange them, you can find a square arrangement that causes all adjacent borders to line up. So the value at the beginning and the value at the end are the same across all the columns, all the rows. Okay. For reference, the IDs are these. Why are these 4 highlighted? To check if you've assembled the image correctly, multiply the IDs of the 4 corner tiles together. If you do this with the assembled tiles from the example above, you get a massive number. All right, let's see what this input looks like. All right, so they're not huge. I was worried the tiles were going to be really, really big. We can parse that. We can parse that. Okay, let's copy that in. And we'll get this one. All right. The first thing we need to think about, I think, conceptually is how many orientations can a single tile take, right? To match a tile, because there are going to probably be candidate tiles that match but don't completely match. And you can find a square arrangement. Is it always a square arrangement? Doesn't say that here, but let's count them up and find out. So let's start parsing these. So line by line, I'm thinking we're going to borrow some code from day 1 here. Parse 1 file name. Yes, this is what we want. This little bit. This little bit. And this will now be 20. And this will be 20. And I want this thing to return, I don't know, lines or tile strings, yeah, something like that. So parse file name, so file name coming in with open file name as file file.read.split on new line. So that will give us these tile strings. So that will be tile strings. I might change the variable from the other thing later. For tile string in tile strings, we're going to get each one. We'll split on new lines. Tile string dot split on new line, and then we're going to have kind of one thing and then all the others. So title, string, tile, and title. How about tile num followed by tile, what do we call it in the actual thing? Like these are image tile contents. Camera array, image tile, monochrome, image. Just say image. So for each one, we get a thing, we get an image. Call them image rows. And then we say tile num Is this always tile and then a thing? Yeah. So let's do L strip, R strip, grab the thing. Regex people would just grab the numbers out of here, but I am a lazy bum. And let's do, just for my own sanity, let's grab the string. A dot L strip tile space, nice, and we'll get everything from the beginning, not including the end. Then we'll convert the whole thing to an integer, and there's our number. Very nice. So we're going to replace tile num with a, or a is tile num. There we go. Replace a with tile num and set it back to tile num now that it's a real number. Great. So that is basically transforming a to, great. And then image rows gets its own treatment. I don't know if there's anything more I want to do with image rows. I could change the hashes to ones and the dots to zeros. Would that help us? I don't know that it would. It probably would help to have a good way to grab all the things out of it. So we should return, let's return a bunch of, so let's have here a list of tiles which will contain the tile num followed by the image rows, and then we'll deal with the class problem later. Tiles.append tile num image rows. And return tiles. And so now we have, yeah, tile strings is probably still a decent name for it. Let's just get the first one here. Oh, I'm still running day 19. Whoops. All right. Still got this problem. All right, we got an unpacking issue. And there we are. So we unpack everything. We have a number. Interesting that it ran part 2 as well. What is part 2 doing? Part 2 usually runs parse line, returns line. Huh. Oh, because usually I return none instead of lines. Yep. I'll just get rid of that. And then we have each of these things. Great. So 1621 we have in our small input. Or am I reading from the main input here? I think I am. So we have dot hash, dot hash, 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 and then the last one is dot hash, dot hash, dot hash. Cool. So now we can definitively move on. Let's move back to the small file in our main function here. And now that we have our title strings, we should make our class. Yeah, let's be real. We need a class for tiles. There's no getting around that. So gotta stop writing title though, otherwise I'm gonna have a bad time. And then we're gonna have like maybe a image class that's made up of tiles. Image. Something like that. Let's see. def init. We're going to pass in the title num tile num image rows self dot num equals tile num self dot image rows. So how do we want to store these? So right now it's a list of strings which we can access as a list of lists. So I think that's okay. Let's just do image, and let's create some helper functions now for finding the edges, right? So and doing flips. So we want a flip. We want a, what are the other transformations that are allowed? Rotated and flipped. Rotated. Oh, def rotate. That's going to be interesting. Times, right? Like how many 90-degree turns do we want? What's funny, of course, the rotation code we can probably steal from one of the previous days. Flipping, and then this should be kind of axis equals x or y, times is 1 through 4, 1 rotation, 2 rotation, 3 rotation. Okay, 3 rotations is the possibilities. And then, so we have to use them all. I'm trying to think about the fact that each one of these has 8 possible states, and we need to select one of those 8 states as a candidate for each of our tiles. Print length of tiles. So that is something I do want to check before we go and try to do more stuff. So there's 144. So 144 with 8 possibilities for each of those 144. So 144, choose 8? No. Is that? Or is it 8? Choose. No, but that's choosing 8 things out of 144. I think the number of raw combinations is literally just 144 times 8, which is considerably smaller. Because for each of the 144 things, we can pick one of 8 options. Yeah, that's okay. I can talk myself into that. And so we could potentially store all 8 things into the tile and kind of just like pull different things. The problem is that the kind of matching, each thing has 4 edges. Okay. Self.flip equals 0. Like we need to have like a flip true or false. X and Y. Flipped X, flipped Y, yes, no. So that's really 4 possibilities because it could be flipped and flipped. Does it talk about the number of? All right, so let's see. If you have this orientation, you have this, this, and this. This flipped is this, which is different from turning it. Now if I flipped it this way, and then I flipped it this way, that's the same as just taking this and turning it. So anytime I have two flips, flip, flip, that doesn't count. Only one flip does something, right? Two flips will always just be a 180-degree rotation. So like if I'm here and I do flip and flip, that's just this again. Okay, so we can only flip on X or flip on Y, never both. All right, so there's this version, and this version. So there's three flipped states. Not flipped, flipped on X, flipped on Y. What do we want to call it? None, X, and Y are the other options. So it's like those three. So it's really 9 possibilities, not 8. 3 times 3 instead of, sorry, rotate should yield 4. 4 times 3, 12 possibilities. 12 times 144, that's 12 cubed. Still reasonable to compute all the possibilities. The real problem is the fact that they're not tight bounds, you know, like it's not like it has to be. But let's compute these first. Okay, the first thing I want to call out is that the contents of the tiles kind of don't matter. Only the edges do. Like when we take, it's basically these frames. We can rotate them, we can, you know, do all sorts of manipulations on them, but they themselves never change. Interesting. Okay. Like we should do the whole thing, but it might be computationally intractable. I mean, they're not that big. Let's just do them. So there are the contents. Here's the flippity flip. Rotate. Self.rotation. Oh, these are functions. So flipped, rotated equals 0. 0 through 3, 4, 3. 0, 1, 2, 3. Good. And then we're going to have some functions to get borders. Yeah. So this will take the current image, self.image, and grab, so this is top equals self.image at 0. Bottom equals self.image at -1. And then left and right will be, left is a string, and right is a string. Whoops. And we're going to go through self.image for string in self.image. Yeah, we're going to go through row by row and grab the first and last element. Left plus equal s at 0. Right plus equal s at -1. So we'll go through row by row, take the first and last characters of each, load them into left and right, and that'll be left and right. Return top, bottom, left, right. And this order will be important. So this grabs the borders relatively inexpensively. I say relatively. Like these recreate strings. I might end up consider replacing with list and joining. All right, let's take care of this flip problem. So to flip an image, we need to so if axis equals x, then the x-axis. So it's like a vertical flip actually. And so we're flipping along the x-axis. We're reversing all of the self.image equals self.image reversed. I think so. And we should have a way to display this. Repra return self.image, basically. But with new lines in between. So it's a list that is going to be new line dot join on this whole thing. Yeah, that should do the trick. And then let's put so that's x. And so when we do it on x, we do self.flip equals x. That's assuming it hasn't already been flipped. So return. Maybe return self, I'm not sure. If axis equals, let's just do elif axis equal to y. Now we need to flip along the y-axis like that, which means that each row needs to be reversed. So self for s in self.image reversed s. So temp image is this list. Temp image is reversed s. No, append reversed s. And then at the end, self.image is temp image. Self.flipped equals y, return. So this fundamentally changes the actual tile itself. And my concern is that every single like there's a y flipped and then rotated, like that counts. So it's like we almost need 2 copies, 3 copies. How can that be? You have this version, you have this version, and you have this version. All right, so I'm gonna get some food and we'll come back and do part 2 of this this one, and we'll do this kind of in parts today. This is in pretty good state. I won't work on this before we continue streaming, yeah, thanks for watching our progress so far. We've got our tiles sorted out, sort of. I'll do some thinking about how I want to fit them together, but we'll see you soon later today.